Today we will be covering lesson 19-1 on the right triangle altitude theorem. This lesson will be chunked into 4 separate sections. We will start with questions 1 to 3. We will look at question 4, question 5, and then we'll finish out with question 6. Let's go ahead and start by taking a look at the introduction to question number 1. It says, you have investigated properties and relationships of sides and angles in similar triangles. In this section, you examine a special characteristic of right triangles. Given the figure with right triangle, MAA, we know that AN is perpendicular to ME, and the measure of angle M is 70 degrees. Determine these angles. Justify that man is similar to AEN. And it says the large triangle is also similar to 2 smaller triangles. Complete the similarity statement, naming the large triangle appropriately. For this particular section for questions 1, 2, and 3, I want you to take about 7 minutes to work through questions 1, 2, and 3. Go ahead and pause your video now. All right. As you can see, the answers to questions 1, 2, and 3 have now been provided. If we take a look, we can see that I went ahead and marked the fact that we said that this was 70 degrees. Well, angle man, MAN, if this is 70, we know that this is 90. So that's 160 together, and we know a total for 180 in a triangle, so that would make this 20. Measure of EAN, well, we know that this is 20, right? Right there in that corner. Well, we know the whole thing is 70. So 20 plus, sorry, not 70. The whole thing is 90, because this is a right angle. If this is 20, that makes this 70, because they total 90. And lastly, it says the measure of angle E. Well, looking at the large triangle, we have MAN, measure of M is 70, measure of MAE is 90, 70 plus 90 is 160, the big triangle should equal 180, so that would make measure of angle E 20. If you have to, I might suggest you do this. Divide it into 3 separate triangles. Here is MAN. We knew that this was a right angle, and we were given that this was 70. Well, by default, that makes this 20. Hold on. Sorry about that. All right. Then split it to this triangle. In this triangle, you had NAE. We knew that this was the right angle. We knew that by default, this was 20, and the full thing was a 90-degree angle. So that would make this angle measure 70, because 20 plus 70 makes that 90. Well, if this is 70, if this is the right angle, that makes this angle, what's left, 20. And then you have the original large triangle. Not drawn to scale, I know, but we know that this was the right angle. This kind of goes back to that process of an angle cannot change sizes. So for instance, M has to stay the 70 degrees by reflexive property, and angle E also has to stay the 20 degrees by the reflexive property. So I took it apart so I could see it in the pieces. Okay, it says man is similar to triangle AEN. Well, we could have used any of these three pieces. We know that angle measure M is congruent to angle measure EAN. We know that man was congruent to angle E, and or we could have even stated M and A is congruent to A and E. Those were my two right angles in those triangles. So I just pulled these from the beginning. We said M was 70, EAM was 70, so those are equal. We know that man is equal to E because those are both 20. And we know that these two, remember, all right angles are congruent. And all I have to do in order to show that they're similar is show that two angles are congruent from one triangle to the other. So that's the reason why at the very end I said and or. We didn't have to know all three pieces. We only had to know two in order for us to use the angle-angle similarity postulate. Now, it says that the large triangle is also similar to the two smaller triangles. Complete the similarity statement, naming the large triangle appropriately. Well, remember that in this small triangle, the tiniest of the three in my opinion, M was the 70, A was the 20 degree, and N was the 90 degree. So we had to make sure that when we look at the large triangle in its entirety, we go from the 70 degree, which was M, my 20 degree, which is E in that case, and then the right angle, which is A. It doesn't matter what order you write it in, as long as it is the same all the way through. For instance, if we chose to write it as MNA, remember that M was the 70 in that triangle, N is the 90, and A was the 20. So whenever I go to write this one, I would have to go from the 70 degree angle to the 90 degree angle to the 20 degree angle. So if I wanted to write it that way, we would write it MAE. So M was congruent to M. N in the small triangle is congruent to A in the big triangle. And A in the small triangle is congruent to E in the big triangle. On to the next set of questions.